two of those were bell ringers that we had. The first one is orthographic projection. So pardon my handwriting as I list this out for you. And this is separate views of 2 dimensions. We'll do some examples. I'm actually going to use our dice activity to do these sketches. Second one is going to be the isometric. And this is what it looks like when you are using your view cube. And you click on the little house on the view cube so that you can see the isometric view. And in parentheses, I'm going to put that as 3D or 3-dimensional. This third one down here is going to be called an oblique. And like the isometric, it is also going to be 3D. And then the final one, maybe you've done this in an art class, is called perspective. And a perspective has a vanishing point, so it is going to be the most realistic of the 4 drawing types. Now all of these that I've identified as 3-dimensional, there are also these 3 go in another category. Isometric, oblique, and perspective go in another category called pictorial. So you'll be seeing these as bell ringers as well. Pictorial means they have 3 dimensions, like a picture. Now, for our orthographic projection, like I said, I'm going to use the dice as an example. These are going to be 3 separate views. Typically, we look at a front view, a top view, and a side view. And often I label these, but since we're doing the dice, I will actually make views out of them. So let's say this is our front view. Let's put 3 holes on this. Let's say this is our side view. So I'm going to put 5 holes on this. And let's say this box up here is going to be our top view. So this is as if you're looking at all 3 views straight on. These are separate views. They're referred to as true size and shape because they should be the actual shape as you're looking directly at it. This is going to be the front view. This is going to be the top view. And in this representation, I gave it a right side view. Now you'll notice that none of these equals 7 because those are in other views. I didn't show the bottom view, I didn't show the left side view, and I didn't show the back. So typically when we're showing, exemplifying these drawing types, we only show front, top, and side. That should give somebody enough information to produce or construct the item. So let's look at this as an isometric. In the isometric, I'm going to start with a leading edge, and then I'm going to have some angled baselines. If I was using drafting equipment for this, or if I was doing this on a computer, these angles would be 30 degrees. My vertical lines in an isometric will stay vertical. Anything that is represented as a horizontal line is going to be at 30 degrees. So as I make this sketch, it almost looks like a book. The top view is always the hardest to sketch because all 4 lines of the top view are angled at 30 degrees. Now if I was to put my points in here, we could say that 3 is the front, 1 is the top, and 5 will be our side. Again, none of these will equal 7 because that's in the bottom, the other side view, or on the back. So this is isometric. Isometric means equal measure. That's because the views are at equal angles. Let's look at the oblique. The oblique is going to have a front view like the orthographic. So it's going to be a flat view of true size and shape. I'll go ahead and put my points in here. So this will be a representation of our front view. And in this example, our side view and our top view recede at an angle. It's a steeper angle than the isometric. If I was to use drafting equipment for this, the angle would be 45 degrees. Here this line's going to be vertical, and this line's going to be horizontal. This one's a little bit easier to sketch than the isometric, just because of the flat lines that are either horizontal or vertical. Those are easier to sketch than the ones that are at an angle. So let me go ahead and finish this view. So here's our top, and here's our right side. That's 5 there. So this is an oblique. It has a front view of true size and shape. Top and side views recede at 45 degrees. It's 3D, so like the isometric, it's also referred to as a pictorial, because it should resemble something like a picture that's in 3 dimensions. The last one is the perspective. This is one you might be familiar with from an art class. Engineers don't often use perspective drawings, but they are the most realistic because the top and the side view recede to a vanishing point, as if we're actually looking at an object. I'm going to do a simple one-point perspective. I'm going to start with a front view of true size and shape, like on my orthographic and on my oblique. So again, I'll use the side with 3 holes. Off here in the upper right-hand corner, I'm going to make a point. We'll call this the vanishing point. This is where our sides will recede to. So I have to carefully sketch these out with very light lines. In drafting and engineering, we refer to these very light lines as construction lines. These are light, barely visible lines that should not be viewed at more than an arm's length away. When drawn correctly, I don't have to go back and erase these lines, but they'll get darkened to the appropriate line style. Here I'm going to place my vertical line to the back edge of my right side view, and I'll go ahead and darken that view so you can see what it looks like. Now notice how the front edge is taller than the back edge, because in a perspective, those edges actually vanish from our viewpoint. Think of you're standing at the corner of a building and you're looking off to the side. This line that I'm going to sketch over here is going to be horizontal. So I will try and keep that line flat. And then I'll go ahead and enclose the box. Since this is our top view, we're just going to place 1 hole on there. There's the perspective. Now for this activity, so that you can better understand it, I'd like you to get a blank sheet of paper and try and sketch these on your own, following this video a second time. So until next time, good luck.